Okay, so we'll make a start. So this session, I guess, is around about some experiments that we've been doing with how to integrate IoT technology into to ArcGIS. And we've been sort of playing around with some indoor tracking capabilities to demonstrate this. So this is a fun session where we've been playing around with IoT, and it's sort of based around my sort of ability to be able to want to answer the question is, how do I find somebody? How do I find one of my colleagues in this big room? It's quite difficult, it's very noisy, so I want to be able to sort of track down where one of my colleagues are. Now, we've been doing that by making use of Raspberry Pi devices. We've got a number of those planted around the exhibition hall here. And as I say, it's kind of it's a demonstration of how you can do remote sensing or data collection using IoT and feeding the information into the ArcGIS platform. And whilst I'm feeding all this information into the platform, I'm then using the ArcGIS runtime product, which is a product that I work on, to visualize the data. So we can potentially show the location of where somebody is. So this is a live demo. There's rather too many moving parts for my comfort. It could all go wrong, but we'll see how we go. And somebody might get hurt, but you know, we'll see what happens. Right, so the goal of this was to produce an indoor tracking system so I could work out where people are. So I want to be able to find various colleagues. People come up to me all day and they say, oh, where's Eric, where's Morton? We want to be able to speak to them. I need to be able to track them down. So what I've done is, in this big room here, I've planted some Raspberry Pi devices. So there's one down here in front of me, and then I've got three more of them sitting underneath some of the stands out in the hall there. And what I'm doing is this is sort of a network of devices which is listening into Bluetooth signals that are being picked up by a number of telephones. So I'm not tracking everybody here. There are issues with doing that. I'm not allowed to do that sort of thing. But I'm just tracking people in my team who have been kind enough to give me their MAC address. And I'm sending. What I'm doing is I'm sort of connecting to those devices, and I'm listening into the signal strengths, and I'm writing all that information from each of the Raspberry Pis into a feature service which I've got in ArcGIS Online. And then I can read all of those signal strengths back out into my runtime application in order to attempt to visualize where somebody is. So let's just take a close look at the Raspberry Pi out of interest. It's a very small computer. I've got one in a case here, but inside the case it's a little bit bigger than a credit card. It costs about $35. It's not particularly expensive, but it's pretty powerful actually. I mean, it contains a 1.2 gigahertz quad-core 64-bit processor. Not bad. It's got a very capable GPU. It's got a gigabyte of memory for running your applications. You actually boot them from an SD card. Now, most commonly they boot from a Debian, a sort of a version of Linux that you can run on these things. But you can also run Windows 10 IoT on these devices as well. So I'm using Linux in this case. It's got 4 USB ports, so you can plug in a keyboard and a mouse. It's got Wi-Fi and Bluetooth. That's very good for what I'm playing with here. It's got a HDMI port, so you can plug it into your monitor. It's got a network port, GPIO as well. So the GPIO, you can probably see there's a sort of a line of sort of extender pins on the top of the board there. So let's take a look at these. So these GPIO pins stands for General Purpose Input Output, and these are the interface with the outside world. So if you want to do data collection with one of these things, you're going to be plugging devices into these pins. And the possibilities are endless, actually. So from a data collection point of view, you might connect in a GPS device. You might have sort of environmental monitoring equipment. So you might want to sort of look at measuring the temperature or light or the compass or barometric pressure. There's a whole loads of these things that you can connect in. And compasses and as well as input devices, you can also configure these pins to be output devices as well. So you can actually use the Raspberry Pi to control motors. So effectively the Raspberry Pi could be a little robot that trundles along the floor that you send off into an inhospitable place in order to be able to send data back. So motors and servos, you can connect them up so that they've got GSM communication. So if you don't have a Wi-Fi connection and you don't want to reel out a very, very long network connection, you can use GSM to send the signals back into your data collection points. Possibilities are really endless. They're quite exciting devices. This is slightly off topic about sort of the data collection, but I just want to sort of talk you through a little bit of output you can do with these things. So you can connect them to motors, or you can connect them to servos. So the servos are sort of very small devices which they've got a spindle on them, and there's an arm which will rotate through 180 degrees, and I can sort of control the direction in which that is pointing in. And typically you find these inside remote controlled cars or remote controlled aeroplanes for sort of changing the direction it steers in, or adjusting the ailerons on your wings or what have you. These are actually controlled by a controller board that sends out what we call pulse width modulation signals. So these devices, you have to think of them as extremely forgetful or extremely stupid, because you have to tell them what you want them to do every 20 milliseconds. I mean, I thought I'm pretty bad, but this is incredible. But what you can do is you can send a signal in and vary the length of that pulse so that you can change the direction of the arm of the servo. So if you vary it between 1 and 2 milliseconds, it will sort of rotate from one direction to the other, and you can sort of get some pretty sort of fine-grained control with these things. We'll come back to that later. So I've got a bit of mischief that we're going to use the servos. I've got the Raspberry Pi connected up to here, and I'm going to go back to Bluetooth, because this is what we're actually which is what we're using to try to connect to my colleagues to work out where they are. Now, in order to be able to see Bluetooth devices, they do need to be enabled. And I'm going to do a little bit of an experiment here, because I'm just going to go and go over to my shell window on the Raspberry Pi, and I'm just going to scan the room to see if we've got any enabled Bluetooth devices in here. And I might expect to see one or two, but I'm not expecting to see a great number of these. Now, if I'd done this experiment 5 years ago, when we all had really old Nokia telephones, they all broadcasted their availability. So, actually, we are getting a few here. I'm hoping I'm not embarrassing anybody here, but we have got somebody's Pro, which is, there's actually quite a few. There's got an iPhone 6. I wasn't expecting that, because I've been scanning this through the week, and there are not many of these devices. Okay, well, we'll cover that up to protect people's privacy. So going back, you either need the devices to be discoverable, or you need to you need to go to people and say, actually, I need the MAC address of your device in order to be able to track it. And once I've got that MAC address, what I can do is I can make a Bluetooth connection to that device. I can then make a query to get the RSSI value. So this is the signal strength that the device believes it's getting from the Raspberry Pi in this case, and then I can close that connection. So each of my Raspberry Pis is going round robin and asking each of the devices that I'm interested in, what's the signal strength? What am I going to do with that data? Well, in this case, I'm actually writing it into a feature service that I've created in ArcGIS Online. So there's a couple of ways in which you can write into a feature service once you've set it up. I guess you could say there's a hard way and there's an easy way of doing it. I chose the hard way foolishly, but never mind, it's good to talk about. So in my application, I wrote some Java code which was using the Apache HTTP client to basically interface with the REST API that is used by the feature service. So I was constructing a HTTP post method that would basically write the attribution information back into the feature service. So I'm kind of giving an update into the central feature service of the signal strengths that I'm getting for each person from each device. Now, that was the hard way of doing it. I could have made life a little bit easier for myself if I'd wanted to write some code using the Runtime SDK. So the Runtime SDK for .NET does actually support deployments to Universal Windows platform applications. So if I'd chosen to install Windows 10 IoT on here, I probably could have made the job of interfacing with the feature service a little bit easier. So there's a couple of options there. I'm a Java person, so I decided not to use the .NET SDK. Right, okay. This is the bit that didn't quite go to plan. I've got these signal strengths coming in, and I wanted to be able to sort of work out, well, how do these signal strengths actually relate to the distance from the device that you're getting this signal strength from? So, well, being a scientific sort of person, I came into the office early one morning when there wasn't anybody about, and I planted one of the Raspberry Pis on the floor, and I ran a 30-meter tape measure up the length of the office. And at the top of the screen there, you can see that there's a chair. So what I've been doing here, I'd got an iPhone and I got a Motorola Android telephone, and I've been gradually moving them up the office 5 more meters, and I was taking measurements to see what kind of signal strengths I was getting out of these. The results were a little bit disappointing. So in the graph that you can see here, so this is all the signal strengths I was reading. So along the top you can see we're going 5, 10, 15, 20, 30. So this is the signal strength I was getting from the different distances. And you can see there is a general trend there, as you would expect, of the signal strength getting weaker the further you get away from the Raspberry Pi. But look at them, they're all over the place. There's no way you can do accurate triangulation with that. Okay, this is where my plan was falling apart. So you can do some estimation here. Now the way I decided to do this was to basically very crudely work out the kind of range, maximum radius you get from a particular signal strength. So if in a mapping application, what I was doing was, if I get a really strong signal strength, and these are actually the most reliable ones, I can draw a small radius. And if I'm getting a weaker signal strength, I can draw a bigger radius. And where they intersect, that can be roughly where the person sits. So it's not brilliant, but it kind of works. I guess you want me to demonstrate that now. So let's have a go. So what I have is Eric Baird, my colleague from the runtime team. He's actually standing out on the Java stand at the moment, and he has a device that I'm tracking. So let's just see if we can make contact with Eric. We're going to call him on Skype. This is the kind of thing that can go very badly wrong. Will it work? Will it work? Answer the phone. Hey, Eric. Hello.
Hey, is that you?
Hello, right. So what I need to do now is actually, I'm just going to sort of bring up the Java application. So I'll just try to position that. That's interesting. We're getting a signal in the right place. This is where my... I was kind of expecting there to be a signal coming from the Java
Could it be there?
stand. Yes. So I was actually expecting there to be a signal that was coming from the Java stand, which is the point in the middle. Actually, it's updated. Make sure you're holding the telephone near to the stand. So the Java stand, where Eric is now, so if you show that is the Java stand, yeah, we're not making this up, he is out there, we haven't recorded this earlier on, it's showing a couple of different signals we're picking up, and we get a strong signal from the Java stand. So I've got 2 other Raspberry Pis now. So I've got one on the drone to map, and I've got one on the ArcGIS enterprise stand. So where should we send Eric? Where should we send Eric? Drone to map or enterprise? Drone to map? Okay, right. We have an instruction for Eric, and he's just going off now to the drone to map section. So he's walking along. You can see his head bobbing. And what you can see now is, I mean...
I know where I'm going.
Yeah? The signal strength...
Can you see me?
Yeah. We can see you. So I'm just sort of talking. It's not particularly quick. But you can see that the
Met the drone to map.
Yeah, all right, so the signal strength is got weaker from the Raspberry Pi that's at the Java stands, but what I'm hoping is that we'll now eventually get a stronger signal which is coming from drone to map, and it will draw a much smaller circle. It's got an absolutely massive one at the moment. Now what I'm doing here is the Raspberry Pis are pinging the telephones every 15 seconds, and the map is actually reading the feature service every 5 seconds.
Yeah.
So I'm going over to the
stay where you are, Eric.
Island. I can't hear you very well because there are lots of people talking and lots of business going on. So
right. Are you?
I can't hear you.
Yeah.
So I'm just going to.
Are you going to drone to map? Drone to map. Drone to map.
I was at drone to map.
Yeah.
Now I'm at Enterprise.
Oh, okay. All right. Stay there. Stay there. Just stay at Enterprise. Ah, look. Are we getting a strong signal? No, it's just the symbol, the marker symbol.
Right.
Okay, we've got a communications problem here. We sent him to the wrong place, but look out, he is there. And okay, we have a strong signal strength now coming from the ArcGIS Enterprise stand. Okay, I haven't got
Should I come back now?
You can do, yeah, that's good. That's a good demonstration. So if you make your way back, have I convinced you that
Okay,
works?
sounds good.
All right, so let me just close that down. And whilst Eric's actually making his way back,
Oh, aren't there many?
we'll just get rid of him. He'll come here in a moment. Actually, oh dear, boring stuff. You get these bits on every part of the talk. Security. If you're working on any IoT projects, then security is actually something you probably should take fairly seriously. Security experts, they're quite snobby about IoT, and they just go, oh, it's the internet of insecure things. You know, they're probably right. So let's just go through. So what should we be doing here? We want to be storing our data in a secured platform. Well, I'm using ArcGIS Online here against an authenticated feature service. So yeah, tick there, I've done that. I think you may need to make sure that you're not able to intercept the remote sensor communications. Oh dear, I'm using plain HTTP to send the messages up here. So, okay, there's some privacy issues here because I'm sort of enabling anyone to work out where Eric is. So that's not necessarily a good thing. So that's something you need to address. Then there's the security of the IoT devices. There are loads of domestic devices like this that people get really excited about and go, oh, I can turn my central heating on before I get home, or I can switch the light bulbs on whilst I'm still at work. And people don't change the default passwords on these things. I have, because obviously there's a community of developers in here, changed the password on these devices. Now that's not an invitation to try and hack them, because I'm going to unplug them all when we finish this session to make sure, but it's something you do need to be careful of. And then there's kind of the, you need to update these devices every so often just to make sure that they're not vulnerable to new security threats. And then of course there's the physical security. You need to make sure that nobody's stolen these devices. This is good, so it was we were able to get it to work. And then there's the physical security. You don't want to bolt them down, or anti-tamper devices. This is the bit I like actually. Let's just, before Eric comes in the room, let's see if I can just sort of set this up. It's the mischief that I was talking about earlier on. Oh, no, it's fine. Don't worry. No, come on. We've done that. We've talked about servos already. That's.
Oh, you did. Okay.
Yes. Right. So what I need to do here is I'm just going to just set this up properly. So let's just get the log running from the device, and we'll bring up the. Oh, actually, that's actually already brought in the signal. So that fairly quickly, that has actually sort of got a nice strong signal. Let's see what happens if we get a really strong signal going on here, and that should eventually sort of make the radius of that go down quite a bit. 15 seconds seems to take a long time. It might not work at all actually, but oh, it's actually got a weaker signal. Oh. Oh, missed. Anti-tamper device to stop people from messing with my devices, but well, obviously I didn't get a chance to practice that, and it's a very crude piece of apparatus, but that's just an example of control with Raspberry Pi, so that's the fun bit. Anyway, that brings you to the end of this session. I'm amazed it worked, so if anybody has any questions, then please ask. Eric will answer them. He was having another go at him. Yes?
Would Wi-Fi be an option over Bluetooth?
Yes. In fact, I've spoken to somebody at this conference who's actually tried just that. And apparently just comparing notes with the two systems. Yeah, sorry, just repeating the question, would Wi-Fi be an option to track people? So the answer is yes, but it does have exactly the same problems in terms of the random signal strengths that you get. So this is a very electromagnetically noisy environment, and you've got signals not going in straight lines, they bounce off things. So again, the triangulation is not particularly good. So it really is, it's kind of like, it's crude proximity analysis that we're doing here. Another option you can consider is there's a new generation of RFID tags out there. Now, typically RFID tags work when you're very, very close, but I've been reading about ones that are available now that have got sort of a 15-meter sort of detection radius on them. So, that's another possibility for being able to detect where people are. So this, I would say, this is very much not a commercially ready environment. It's just an experiment. So, any more questions? Okay, well, thank you very much, and thank you, Eric, for agreeing to be abused in such a bad way. If you've got any questions, come and see us. Thank you.